Hi, my name is Diego Câmara Salles. I'm a PhD student at University Federal of Santa Catarina and present my paper, The Ontology and Rules for Characterization of Sensors and Actuators Devices in AADL Models. The presentation are organized in motivation and introduction, background and related works, ontology of sensors and actuators characterization, and conclusion and future works. The core motivation is the cyber-physical systems are complex systems that use intensive sensors and actuators in the architecture. New technologies from sensors and actuators devices enable new functionalities and improvements in quality characteristics that instigate the evolution of architectural system by trade-off devices to accomplish new functional and non-functional requirements, extending the project life cycle, supporting new applications. Identify the sensors and actuators candidates that has architectural compatibility, measuring components impact is a challenge. How to select and exchange the sensors and actuators device on an architecture? What are the characteristics and properties that should be surveyed to meeting functional and non-functional requirements when occurs the trade-off component? Previous team works propose approach targeting sensors and actuators modeling with focus in translation model from functional Simulink model to AADL model with a few quantity of properties to be evaluated. And now we can exchange this characterization of sensors and actuators to model in system architecture. One way to model the sensors and actuators characteristics is using ontology. Ontology is a way of highlight the features, characteristics, properties, or parameters of a subject and showing how they are related by defining a set of concepts and categories that represent the subject in a specific domain. The sensors and actuators ontology support map characteristics and properties that support this paper, this project. The World Wide Web Consortium already proposed sensors and actuators ontologies. However, the actuator components are represented as abstract. An actuatory device, component device, trade-off need to be evaluated to measure the impact when you need exchange these devices. However, the actuator components are represented as abstract. In this point, it's necessary to describe more details about these components to evaluate the exchange device and help define proprietary set specification to support the design architectural models. Related works research about sensors and actuators ontologies that propose a set of frameworks, for example, observation and measurement, sensor stimulus observation, SSO, sensor model language, sensor ML, semantic sensor network, SSN, Sensor, Observation, Sample, and Actuator (SOSA) framework. The last two ontologies provide an extensive framework with 23 ontologies and relationships that details the interaction of sensors network application, abstracting the architecture components. This work proposes a reuse of ontologies and alignment to provide ontologies for architectural system application. We focus on design, the trade-off design. The semantic sensor networks has include device class and expand details about the sensors using a class named measurement capability. The sensor observation sample and actuators propose 23 frameworks ontologies and includes the device class with the same information about SSN, but include the sample and the actuators class. But in all these two ontologies, the architectural components are declared as abstract. Abstract components of the architectural components are declared as abstract and did not address the components, considering only the platform and procedure class, with limitation in evaluate the other components of architecture systems. So, in this paper, we propose a sensor and actuator characterization ontology to support architectural system design alignment with SOSA framework to future standard application focusing architectural systems. The proposed ontology reuse SOSA framework expanding the platform and procedure class, which are replaced by components of the architecture. To describe architectural components in this work, we propose an architectural component based on AADL models that has interaction and relationships with SOSA frameworks and structured the sensors and actuators characterization using ISO IEC 25010 quality model standard. The architectural analysis design language allow represent models of architectural systems detail on components composite, features, and proprietors. So, for example, in figure 3, we have all the components that can be modeled in AADL. The system components or subcomponents, devices, processor, bus, memory that integrate in a system implemented architecture system. The ISO IEC 25010 standard is a system and software quality requirement and evaluation that support structure characteristics, quality characteristics, and attributes of an architectural system. With this standard, it is possible to structure classes and subclasses of sensors and actuators characteristics. The ontology of sensors and actuator characteristics start with the alignment with the SOSA framework. The ontology relationships are proposed to integrate the architectural system components with AADL components and the ISO 25010 quality attributes. Over here, we have the AADL components class that have integration with SOSA framework, SOSA sensors, observation and proprietors and results, and actuators. This AADL components has a component property that is a subclass of property, and these properties has the standard ISO 25010. This is the class SOSA sensors and actuators that have the alignment with the proposed ontology. Research in online stores, device manufacturers, and related works that define the classification of sensors and actuators provide information to model a structure of ontology, class and subclasses, using ontology web language and protégé tool. Over here, in figure 6, we have the types of sensors. In figure 7, we have the type of actuators in your classification. Another class that is related is the measurement objective class that define the related measurement between the sensors and actuators. For example, in figure 8, we have the measurement objective that could be used in architecture systems from sensors and actuators and architecture. Over here, the AADL components are shown in figure 9. The device component is a component that has properties and has features. The question is, which are they for sensors and actuators? Which properties and features? More details we can see in another ontology that has the AADL features that could be defined as data type, bus, port type. The property is a class that supports sensors and actuators properties with measurement objective and architectural components properties integration. The source actuator and sensors still alignment with device implementation and has features and properties. The sensors and the actuators properties provide information to elucidate the trade-off candidates. In total, 32 characteristics are identified to support trade-off device evaluation in architecture system. It is important that properties are structured by ISO AEC 25010 standard to evaluate quality models. These characteristics provide information about the mechanical structure, the, the behavior, and the management information about the devices that support more details and characterization of sensors and actuators modeled in OWL model. Combining these model ontologies of AADL, sensor and actuator characteristics, and ISO 25010 standard in semantic web rule language, it is possible to define rules and axioms to provide the relationship between the ontologies. An example of rules to describe sensors are shown here, sensors and ISO characteristics. The sensor rules example describe is a device, out data port, has bus, has properties, is flow source, then this is a sensor. In ISO rule we have is a device. This device has software integrated, has required bus access, then this is a functional suitability characteristic. The OWL and rules support the development of AADL plugins, analysis, and for evaluation of specific properties of sensors and actuators, creating the property set with sensors and actuators characteristics, and create a library with structure sensors and actuators types, focusing quality model. Over here we have in figure 13 the property set example about describing in AADL model how to define the property set to describe types of sensors and actuators. In the figure 14 we have the device model that use these property sets in the model of a device in AADL model. So the OWL and rules from semantic web rule language models support architecture models design and analysis of creation of plugins in OSAT tools. As future works, we propose automatic transformation engine from OWL models to AADL model, providing the device library and property set of architecture system. So this is the reference paper, and thank you so much.